All right, let's jump right in. Building those really powerful natural language processing applications, the kind that can actually understand and even generate human language, well, that's not magic. It really comes down to having the right set of tools. Think of them as digital power tools. And today, we're going to look at the frameworks that make it all happen.
Okay, that all sounds great, but if you want to build something with this cutting-edge NLP, honestly, where do you even start?
You start with the right tools, and in this world, they're called deep learning libraries. They are, without a doubt, the foundation for pretty much all modern machine learning.
So, what is a deep learning library, really? Well, at its heart, it's a supercharged numerical computation library. You can think of it as a specialized math toolkit for Python, one that's just incredibly good at handling these huge multidimensional arrays. And it turns out that specific skill makes it the absolute perfect choice for building and training neural networks. Got it. So if these libraries are the toolkits, what are the main options out there? Who are the big players? Well, you can really see the evolution right here. It all kind of started with academic pioneers like Theano, which laid all the groundwork. But then, as machine learning just exploded in scale, Google stepped in and said, we need something more industrial. And that's how we got TensorFlow. But TensorFlow is pretty complex, so that created a new problem, usability. And that's where keras came in, giving everyone a much simpler, more user-friendly way to tap into all that power. This is a fantastic way to understand the relationship between the two biggest names today. If you've ever worked with databases, just think of TensorFlow as the core database engine. It's incredibly powerful, it's complex, and it does all the real heavy lifting. Keras, on the other hand, is like a simple, high-level query tool. It's that friendly interface that lets you get the results you want fast, without having to be an expert on everything happening under the hood. So that makes me wonder, why not just code everything from scratch? What's the real practical advantage of using one of these big frameworks? That is a great question. And the answer really is all about scale. These frameworks are built to handle massive data sets and run across huge computing clusters, sometimes thousands of machines at once. To do that, they represent all the math as something called a data flow graph. Again, for the database folks, think of it like a query plan. Instead of just running commands one by one, the framework maps out the entire computation first. That lets it figure out the most efficient way to get the job done and distribute the work, making it incredibly optimized for performance. Okay, you keep mentioning performance and massive scale. What kind of hardware are we talking about here? This doesn't sound like something you can run on a laptop. You're right, it isn't. We're talking about an immense amount of computing power. Seriously, training just one of these complex models can take billions and billions of calculations. Trying to do that on a standard processor, it's not just slow, it's pretty much impossible. And this is exactly where specialized hardware comes into play, specifically graphics processing units, or GPUs. Just look at the difference here, it's staggering. GPUs were designed from the ground up to do tons of calculations all at the same time, in parallel. And that happens to be exactly what you need for training neural networks. We're not talking about a small speed boost. It can be 100 times faster, or even more. This huge performance gap is precisely why GPUs have become absolutely fundamental for modern deep learning. It's not just about making things faster, it's about making them possible in the first place. This leap in computing power is what lets us build the bigger, more complex, and ultimately more accurate models we have today. Okay, so if we're going to boil this all down, what's the final takeaway? Let's wrap it all up. At the heart of modern NLP, you have a powerful engine like TensorFlow. That power is made much more accessible thanks to user-friendly interfaces like keras. These tools are absolutely essential for handling the massive projects we see today, but you only unlock their true potential when you pair them with the incredible parallel processing power of GPUs. It's really that combination of software and hardware that makes modern AI possible. So, we've seen how this incredible combination of software libraries and specialized hardware has really fueled this amazing boom in NLP. It kind of makes you wonder, as our models get even more complex, what's next? Will the next big breakthrough come from even better software, or from some entirely new kind of hardware that we haven't even thought of yet? Something to think about. Anyway, if this explainer helps you get a handle on the tools of today, please do like, share, and subscribe for more. Thanks for watching.